Hello everyone, welcome to this video. So in this video, we will look at differential equations for JEE Mains and JEE Advanced and also for ISI CMI. The syllabus is pretty much the same. So we will only look at the differential equations of first order, which are linear differential equations. But note that there are other differential equations, of course, which also needs to be studied just to have an edge over these exams. That will be given in the next video. But for that, you must first of all master this form right. So the ones I'm talking about, which I'll provide later on, is something on second order differential equations and how to form characteristic equations, how to use matrices to solve them. But we'll get on that in the next video. But for now, let's see. So if a equation is of this form where you have dy by dx plus p of x into y equals to q of x, so you're solving for y and y is a variable of x, let's say, and this is the form you have. So you have a simple term dy by dx, and then you have the term y, which is linear, multiplied by some function of x, and this whole thing is equal to some function of x. These are called linear differential equations of first order, and there's a pretty simple way, step-by-step process to solve them instantly. So let's go on and see what process can be used. So the thing is, first of all, we need to rearrange any given equation, which is in the linear differential equation form of first order, into this format. So you first write the derivative of the function which you're solving for. So if even if it has any coefficient, you just divide the coefficient. So let's say it had an x or 1 by x. So if it had an x, you would divide the whole both sides by x, or if it had an 1 by x, you would simply multiply x on both sides and you transform it into this form. Okay. Once you do that, next step is to find the integrating factor, which is the most important part. So what is the IF? So we'll call it IF for short. The integrating factor is simply the coefficient function of f of x or the coefficient function of y, which is in obviously f of x itself. We can write either y or f of x both. So it's basically the function p of x that is attached to this y or f of x. We need to find the integration of that p, but the answer should be exponentiated. So basically, the integrating factor is e to the power and then the integral of p dx. Notice that you do not need to add any constant plus c while doing this integration. Okay. The third step is simply find the integral of if into q. So you have the q function on the right hand side. You also need to find the integral of if into q dx, and you are done with the solution, because the solution can simply be given as f of x is equals to 1 by integrating factor multiplied by the last integral that you found. That is your answer. And obviously, in this integral, you need to do the plus c so that you can eliminate the plus c if you have any initial values given for f of x by putting that value of x, right? So, with this in mind, let us go ahead and see two examples from JEE Advanced PYQs to strengthen our basics and also understand how to solve them step by step. So, here we are in the PYQ section. So, let's start with this one. This problem came in JEE Advanced 2023, paper 2 in the online, and it was an MCQ type of question. So let's read the question. We have a function f with some domain and it goes to real numbers. The important part is that it's a differentiable function. It's very important to note, because you know how I always stress upon on these small details. Given that f of 1 is 1 by 3, and then you are given some equation, and then basically we have to find the value of f of e. Okay. Now we will start with the equation. So this is our given equation, right? Now understand that since f is differentiable, the first thought that should come to your mind is, can I differentiate this function? Because there is an integral and we do not really want an integral, right? We do not really want to work with an integral. And also you see there is a variable on power. There is a variable in the limits of the integral, right? So we use Leibniz rule of differentiation under the integral sign, which has been explained in other videos. You can check out my previous videos on integration. So once you do that, you simply are differentiating both sides with respect to x. It's as simple as that, right? Once you do that, you get this equation. Okay. Now, this can be simplified. So what happened is basically d dx of 1 to x ft dt is nothing but f of x dx. Because when you differentiate, what you do is you basically differentiate the upper limit, and then you put the value of the upper limit inside the whole function. So you differentiated x to get 1, put the value to get f of x. And again, you differentiate to the lower limit, but this time it's 0, and that is why there is no other term. Okay. And the rest two differentiations are easy. We are basically using product rule and power rule. Okay. So once we rearrange, we now have a differential equation at hand. And as we learned in theory, we simply have to rearrange. Once we rearrange this and divide by all the coefficients and stuff, we get this equation right here. Okay. Now, what is the step? We have to find the integrating factor. So you identify that, okay, the coefficient of f of x is nothing but minus 2 by x. Remember, obviously, we have the minus as well because initially the form was in positive, right? Like this. So the integrating factor is e to the power minus 2 by x dx. 2 by x is 2 ln x. So minus 2 ln x should be ln of x to the power minus 2. So this is nothing but e to the power minus ln of x to the power, sorry, this, and this would lead to x to the power minus 2. Now you already know the solution is given by fx equals to 1 by if. So I've just written here if into fx, which is where if is your x to the power minus 2, is equals to the last integral that you're required to calculate, which is if into q, where your q is nothing but x. This is a pretty simple task, and once you do all the details, you simply get this result here. You can see that even in explaining this, I took let's say 1.5 minutes, but while actually doing the sums, once you know the method, it will take you less than 20 to 30 seconds to reach up to this point because you know what's going to happen, right? You already have it mapped out. You know that I have an equation like this, I have to differentiate, I have to rearrange, and then I have to simply find the if. Once I find the if, I can write that solution directly. Okay, I have one more integral, I'm going to evaluate it because it's too easy, and then you simply have this. Now remember that you had f of 1 equals to 1 by 3 and initial value was given, and thus from that we can simply find out c is 1 by 3 and then put the value to get f of e is 4e squared by 3. Easy, right? So even J advanced questions are way too easy once you know what to do. Okay, so in maths, what happens is if you have your basics and your applications are good, like if you have practiced a lot, these questions won't be that much tough as they look out or as they make out to be. Okay. Of course, in proper integration questions, it might get a little bit of tough according to your standards, but well, then again, it's also all doable. Okay, let's go to another one. So this is again a question from J Advanced 2014, paper 2. Paper 2 is usually tougher in J Advanced. So you have this equation here, dy by dx and stuff. Satisfying f of 0 is 0, and you're simply asked to find this value of this integral. Do not be confused by this d of x. This is nothing but dx because, well, derivative of x is dx, right? Okay. Again, we don't need to panic or do anything. We simply understand that this is given in the form, as I said, this form, right? This is given in the form where you have dy by dx plus py equals to q. So you know what your p is. Your p is x by x square minus 1. Integrating factor can be found out using this integration. This integration is also simple because you see that the derivative of x square minus 1, which is 2x, is already present, but there is a 2 missing, so you just adjust it, right? And then again, you put the half power inside the logarithm and take the logarithm outside completely to get this. We have done this because we know that x is between the limits minus 1 to 1, so x square minus 1 would not make sense. We need a positive value. 1 minus x square is something we need. Okay. Again, the solution is given by y into the integrating factor equals to the integration of this thing. Now you see the entire thing basically cancels off. Solve this to get this part. Now, again, since f of 0 is 0, you simply get c equals to 0 and your function becomes this. Okay. Now, finally, we have to find the integral of minus root 3 by 2 to plus root 3 by 2 of fx. Now, once we do that, we see there are two parts to f of x, right? So obviously the first part, if you notice, it's an odd function because the denominator is even, but the numerator is odd. And since it's an odd function, we know that any limit of the form minus a to plus a of an odd function goes to 0. We have learned this in definite integration theory, right? So the first integral is not even something we need to be bothered about because it becomes 0. The second integral, however, is something we need to find out. So I is nothing but simply this integral. You simply can put x equals to sine theta because you see this term root over 1 minus x square, which basically allows you to think, okay, so I need to put some trigonometric function here, x or x equals to sine theta or x equals to cos theta, both work. Well, sine theta is better because I prefer it because the dx is not negative. So dx simply gives you cos theta d theta, right? And even the limits are easier to calculate. So once you do that, you get this. Again, using properties, you see this is a even function. You can simply write 2 times 0 to pi by 3 sine square theta d theta, and you can evaluate this pretty easily by using the half angle formulas or the double angle formulas. Like the 2 sine square theta is basically equals to, I think, 1 minus cos 2 theta, right? So you can do all those and get this value where you have pi by 3 minus root 3 by 4, which is a required answer. So the only point where you would need some time is to find out this basic part. So this is the part which might take 1 minute of your time. And the other part, this whole part should take your time, like 1 more minute. So this should be a 2 minute problem at max parts, of course. Like not like if you have just started out differential equations and you went to give on the exam directly. That's not when it's going to happen. But obviously, you need to practice it a lot and understand all the basics. So what we'll do is we'll learn about those extra techniques in the next video, and we'll also solve, let's say, 5 to 10 more problems in this chapter to make sure we take it off the list and that there is nothing more to be done in this chapter because this is an easy chapter. So thank you for watching. Also check out the blog description in the comments below, and you can find all sorts of mathematical posts there.